over and start the panel session. Thank you, everyone.
Thank you very much, Divendu. Very good morning to all of you and a warm welcome to this panel discussion on AI for disaster resilient infrastructure. I'm just moderating. All the hard work at the back end has been done by Dipali and Divendu. So maybe even before I start, I think they actually deserve a round of applause because all the hard work they have put into, put together this session. So as we have a very tight format, we have been given 55 minutes, out of which 10 minutes is already gone, and we have to vacate this room sharp at 11:30 for the next session. It's pity because we have such a diverse set of speakers with us who bring in real, on-ground practical experiences and insight. We won't get too much of time to hear from all of you, but what we will have is at least 3 to 4 minutes for each one of you. So we have tried to have very targeted questions for each one of you. With that, maybe let me first invite all our panelists and speakers to the dais because I think they want to take a photograph as well. So at the very first, let me request Rita Misal to kindly come and join us. Rita is the member, National Disaster Management Authority. She comes with decades of experience on disaster risk reduction and recovery. And prior to joining NDMA, she was with UNDP. May I request, Rita, please. May I request Dr. Pradeep Thapliyal from ISRO to kindly join us. He's the Group Director, Atmospheric and Ocean Sciences Group, Space Application Center, Ahmedabad. Dr. Thapliyal, thank you very much for joining us today. Samhita she's the founding CEO of Resilience AI. And Samhita is a disaster management practitioner working at the intersection of humanitarian system, corporate governance, and advanced technology for institutional resilience. Thank you. Dr. Manavendra Saharia from IIT Delhi. Dr. Mahavendra Saharia has a long association with CDRI. He is one of our CDRI fellows. He has done some cutting-edge research on application of AI to come up with integrated model which helps in decision-making and particularly flood forecasting. So thank you very much for joining us. Kimberly Brown, Head of Mobile for Humanitarian Innovation and Emerging Tech, Mobile for Development, GSMA. Kimberly leads GSMA's Emerging Tech and Mobile for Humanitarian Innovation programs that harness the power of AI, and we're absolutely delighted to have you with us. May I now request again Anshu, who is again a kind of a champion of CDRI. He works closely with us. Anshu again comes with decades of experience in the field of disaster risk reduction, climate resilience, and governance innovation. He's the co-founder of SEEDS and also kind of looking after the SEEDS technical services. Thank you very much, Anshu, for joining us. The seventh speaker that we have, Dr. Srikanth K. Panigrahi. He's the Director General of Indian Institute of Sustainable Development, but I understand he's still stuck in traffic. He might take another 10-15 minutes more to join us. Maybe I will pose the last question to him. And with this, we will start the panel discussion, but I think the organizers want to take a group photo. So yeah, you may kindly take a minute to click the photo and then we can start the conversation. I'm very much visible from here, so it's okay.
Yes, please look here. Wait, please. Thank you.
Thank you. So before we start with the panel discussion, let me set the context a bit. Why are we at all organizing this session? So around the globe, the infrastructure systems are growing under tremendous pressure from extreme weather events, aging assets to the demand of energy transition, urbanization, and accelerating technology change. We, as you must have heard by now, we work on building resilience of infrastructure. We are a coalition we have come up with a Giri Data Platform, which is an infrastructure risk assessment tool, which already tells us that worldwide, the amount of average annual losses that might be incurred due to damage to infrastructure is already more than $700 billion. And this only looks at the damage to the physical assets. This does not consider the losses that incurs due to disruption of infrastructure services. And if we consider that, the amount will be 7.4 times more. So that's just one kind of an analytics. But what we also see that in amidst of all these challenges, there lies a significant opportunity, because our research tells us that more than half of the world's infrastructure needed by 2050 are yet to be built. And that gives us, an opportunity to make them resilient, intelligent, and adaptable. And technology can play a transformative role on how we look at our infrastructure, how we build resilience of our infrastructure, because AI offers innumerable transformative opportunities to enhance the resilience across the intricately interconnected infrastructure system. Because when we look at resilient infrastructure, we don't look at the asset only. We talk about a resilient infrastructure is a system, a network of services which has the capacity to absorb the shock, to respond to the shock, and to recover from the shocks. So that's the kind of perspective we are using when we are talking about resilient infrastructure. And we are already seeing that AI is rapidly transitioning from being experimental to become an important part of the solution. So it is not only an innovation, but it can also become a very strategic enabler to build resilience of infrastructure. So in today's kind of panel discussion, what we are trying to see is that we are organizing it under the aegis of AI Summit, which itself is a privilege for CDRI to be a part of such a big Global South AI Summit, which is happening in India. And we would like to explore insights, draw inspirations from the examples that our speakers will share, and also deliberate on what are the issues, challenges to scale up AI, take it from experiment to scalable solutions. So that's the scope of today's panel discussion. Because it has a tight format, what we are trying to focus on 3 specific pillars: how to enhance the data value chain for building resilience of infrastructure. We are trying to look at how we can use AI for improving connectivity, communications, and collaborations. And the third, we are trying to focus on how to use AI for strengthening infrastructure assets and network performances. And also we have tried to align this with the overall, the pillars of this summit, which looks at people, which looks at planet, and looks at progress. Because at the end of the day, technology is for people, is to make people's life better. With that, maybe I kind of request Rita Misal, who is member NDMA, and we are really grateful to Rita for agreeing to join us today despite her very busy schedule. And Rita also comes with decades of experience on disaster risk reduction, particularly post-disaster response, recovery, and resilient recovery planning. So Rita, I'm requesting Rita to give a special address and share her perspective on how technologies, including AI, can be a game changer in building infrastructure resilience. Rita, the floor is yours. Thank you.
Thanks so much, Ranjini, and it's a pleasure to come to this session with CDRI. Thanks, CDRI, for inviting me. Thanks also to this wonderful group of panelists that we have here. It's a pleasure. Actually, it will be my pleasure to listen to all of you because, I don't have the solutions and I'm hoping some of them will come from you. But what I wanted to also start with, as I mostly try to focus, is a more pragmatic question to all of these with a strong example of what I have faced very recently in my first few weeks of joining National Disaster Mitigation Management Authority. I went to Odisha, and when I went to Odisha, and one of my now the HOD, Dr. Vatsa, encouraged me, when you're going to Odisha, do a field visit to a village called Satbhaya. Satbhaya has been a long story of displacement over decades due to repeated cyclones, and now people are resettled in a colony. And I visited Satbhaya, the coastline, and I went to the community as well. Now, their move to the community was after the third cyclone that they agreed that they will resettle. Obviously, they lost all the agricultural land. They lost the fisher folk lost their trade as such. They are now about 7 or 8 kilometers. It is forested land, and so there is no access any more to that. So, had AI been applied, how could this have, even now, the place that they are living is very close to the river. They're not near the sea, but they're close to the river. How can riverine erosion be prevented through AI? That was, the first thing that people said, that we came in from the frying pan into the fire in many ways, because there we were facing the sea, and here we are facing the river, and there's a probability of our current village also being submerged as well. That's one problem. The second problem that when I went to Odisha State Disaster Mitigation Authority, they made a beautiful presentation on their failures, which is quite unusual. When you have someone from the Disaster Management Authority in the national level living in the state, they want to show off usually all the things that they have done well. But this State Disaster Management Authority wanted to show me the failures in how they have been unable to address the issue of coastal and riverine erosion. At every point of time, they say we seem to patch up one piece of land, and the next piece of land, after several years, we see that other piece of land along the same coastline or river is broken down, so we don't know whether the impact of it or what is happening. But this is a list of failures that we have spent crores of rupees, and we have not been successful yet to address the main problem. And NDMA has a coastal erosion project, a mitigation project, coastal erosion mitigation project, which is also 500 to 600 crores running in 3-4 states, and urban flood mitigation project as well in 3 states. And so today the big question is that, in these particular programs, to these particular people in this village that came away from the displacement, and the state government authority, that is where the action takes place, decisions take place, how can AI be enabled? So I do not want to give too much statistics about how infrastructure losses are continuing. Only from my experience, again, from being the past few months in NDMA, I'm entering into my 3rd month in NDMA. In 2 years, we have been doing post-disaster needs assessments in all these states, and in around 11 states, the absolute asset loss, infrastructure asset loss, I'm not even counting health sector and social sectors and all that. When we have an infrastructure category, let alone the health and social infrastructure and other infrastructure, has been 19,000 crore direct damage. And if I look at the stats that Ranjani presented now, that could be 7 times more if it was indirect losses that was accounted for, right? So this is the volume of loss that I am dealing with, let alone others. And then so this growing risk, and then all this infrastructure is going to be recovered at much higher cost, reconstructed at much higher cost in the mostly Himalayan states. The states I mentioned that were affected by flood, you would know last year's, were J&K, Himachal, Uttarakhand. They're the 3 main states that form the majority of the losses, economic losses against asset losses. And of course, there is Punjab and a few northeastern states as well, including Andhra Pradesh, Telangana, and others. So there is a huge task ahead of us. And so what are we trying to discuss here? What are the solutions that we can think about? And the other thing, the role of AI, specifically in planning infrastructure, in terms of its location, in terms of understanding what risks it's going to face in its lifetime, climate scenarios for a longer period of time. And secondly, what about operation and maintenance? All of these factors, I think, come into discussion. I think you will come with those points, I'm sure. Meanwhile, also, you would have heard the budget for 2026, right? The 2026 budget has almost 12 lakh crores in capital expenditure, with 7 new rail corridors, 20 new national water highways, a lot of investment in tier 1 and tier 2 cities. So even if we look behind or look ahead of us, there is a huge role for us to play in defining what exactly our infrastructure is look like. So if it is supposed to be resilient to climate change, resilient to other kind of hazard as well, So that's the scale of what we are looking at. And so within NDMA, I think one of the things that we can only think about is, so far as Lanjini mentioned, that we have seen very successful experiments, both with Samhita and SEEDS together, the Heat Action Resilience Plan. Yes, congratulations AI Resilience AI for winning the award on Resilience 360. A big applause for them because it was one of the few shortlisted ones from all the thousands that came. Those are two small examples we have seen. The scale of the problem is so much more larger. So how do we then, what she said is move from pilots or experiments to scalable solutions, and there has to be a strategy for the governance of giving this taking this technology, AI technology, right from the national level, from experts like you all, from institutions like AIT and ISRO and other places, to the government people who need to understand this and apply it. That's where I think there is a huge gap. So while we are talking about harnessing AI technology for all of that, there is still the basic digital divide in which people are scared to look at AI in such a way that it can be seen as a tool for helping them, because the negativity surrounding this beast is making much more larger noises. So how do we then break into that fold of making a bridge between what we are proposing, the experiments we have done, the successes we have seen, to take it down to the national level? So that's one of the things that I wanted to bring to your attention. Third, I think, when we are talking about recovery, because that's my area of work, I would be very keen to see exactly, and I read the Giri report when it says if you accelerate reconstruction, you will be saving a lot more in investments, in future investment and things like that. That kind of political analysis and the financial analysis that should be shown at the state level and to finance ministries as well. People who deal with finance is very, very critical, because sometimes delays happen during the reconstruction project, and small infrastructure projects, it would be rare for any infrastructure project to be completed in time, right? So presenting that analysis to policymakers at the state level where the construction is actually taking place is very important. Thirdly, I would like to think about also capacity building in a different way. Capacity building for those set of technical people who are actually going to be involved in this, which is our government engineers. So when we are talking about the coastal erosion projects, we have a whole slew of engineers from different departments, whether it is CWC, PWD, RD, and all of these people who are going to be engaged in the coastal erosion project, right? And so how do we then move what we have learned into smaller modules of learning so that the learning can be transferred and applied, So this I think is something that I feel is achievable through what we are trying to do here today. And my final point, and I have already mentioned that, but also there is this whole discussion of high upfront investment cost. For each project such as this, what would be the upfront investment cost? We have to understand that and present it, because when we present solutions to the state government, the first thing they're going to ask is how much is it going to cost us to ask GSMA or AI, Resilience AI or SEEDS or any other institutions to set up this system for them to do the analytics for that. So upfront investment cost. Next one is, what is the other thing that we talk about is the upfront data needs. Data is not everywhere presented in such a manner that it is possible for people to use immediately. So how are we storing data? What kind of data is needed? Is that already someplace, scripted so that people can see and say, yes, we already have this, So I see these as the barriers that we have to really overcome before we get into the whole dirty hands work of trying to make. So for me, it's about, as we will try as much as possible to create an enabling atmosphere between being the bridge between the states and yourselves, the technical experts here. And then secondly, between us and the infrastructure operators who are actually going to do it. then the thing is, while we are talking about transformational tool, we must allow the transformation to be charted out in steps, that one of the other two or both of it together, so that the lives of people are actually protected. So thank you very much. And also thanks CDRI again for this opportunity. We are very pleased to, be part of the CDRI and the GIRI report. And I'm sure that, this is a lot on this front on AI capabilities. Thank you.
Thank you, Rita. You made several insightful remarks. I won't take time to summarize them now because we don't have too much of time for the session. But a very important point is how to build the capacity of the public institutions to embed AI in their businesses and further use it for doing resilience planning, mitigation planning, and even reconstruction planning. So that's the one crucial takeaway for me from what you spoke. You of course mentioned about data, and we have Dr. Thapliyal from ISRO. Dr. Thapliyal, you have been using AI for satellite imagery analysis and providing risk analytics like inundation mapping, flood predictions, and different forms of risk information. According to you, how can these AI-generated risk insights can be, converted into targeted advisories and used by infrastructure agencies? Can they really use it? Are they already using it? Some examples. And what are the challenges and gaps that exist on ground to use this analytics for very targeted actions like advisories and SOPs for the infrastructure operators? Over to you. You can make your comments from there. Yeah.
Thank you. So, just now we were talking about the data. Actually, when you want to discuss about disaster management, the first foremost important thing is data. So we from ISRO, our first focus is providing the data which you require from satellite, and the data are related to weather informations. Like we have our own insert series of satellite where you have cloud imagery, you have three-dimensional temperature humidity profile estimations, and then you have other maps for this geospatial analysis of this digital elevation model. You have resource monitoring satellites. So with the availability of this very high resolution model, you have all the data which is used for AI type of applications, wherever you want to say that flood monitoring. So now start with the prediction. So the AI is used for, first of all, retrieval of parameter. What are the parameters required for this prediction? Like cloudburst, the most important thing is rainfall. How much rainfall is going to happen over one particular location? So when that information is generated, so physics-based models are, they're little slow. So you have to, even when speed is required, you need to have those AI type of models inbuilt with your satellite data. And when you locate the place where the cloudburst is happening, then the second thing is where it is going to affect. It's not affecting only one location. That location may not be inhabited, but downstream there are these floodplains. Okay, so if you have those geospatial maps available, you have the knowledge of settlements where people are living, which are the vulnerable sections where people are staying near to the river banks. So those warnings can be given in time, and then AI can help in that how to send these alert to targeted people. It's not just that you hear from radio or TV that there will be heavy rain or there will be flood. So this information should reach targeted people. Second thing is like cyclone. So cyclone also similar thing. The data there is huge amount of data coming, and in future, it will be even 100 times more data from our INSAT fourth generation of satellite. Now, how to analyze that satellite data to get that information where the cyclone is going to hit, which coastal area, where there will be this storm surge, inundation because of heavy wind, where there will be large rainfalls. All these informations can be provided to the localized, where this impact-based forecasting you have to provide, and AI will help a lot in that. The third thing is like lightning. So we are also going to have that satellite where you can provide real-time lightning information from satellite over all Indian region. But that information, how it will reach to the farmers? The farmer is out on the field. They do not know when and where this lightning will happen. So how to take these forecasts to that farm level, to the farmer, so that he can go to the safe place and save his life. So there are many such examples where starting from retrieval, the forecasting, there also you need this AI application. The third thing is to disseminate this information to the suitable people, to the target prediction. The fourth thing is the climate resilience. Now you have huge data for past 30, 40 years. Can you make use of AI applications and then see how climate is going to change? There are various parameters like thunderstorm is there, lighting is there, cyclone. Cyclone, you know that intensity is increasing day by day. Cyclone frequency as well as intensity. So how to make your infrastructure this climate resilient? So you know that what will be the intensity of cyclone during next 10 years or 20 years. So you can be well planned for those type of eventualities. So these are the few points. I will not take much time because if there are specific questions, I can answer those later on.
Thank you. So basically, as we heard from you that, physics-based model when combined with AI can be transformative towards building the resilience of infrastructure system. And the point that Rita raised, that how do we know, have the risk information on the basis of which we site our infrastructure. So satellite imagery has the potential to provide that, but then there is a skill gap. There is a gap in the capacity. There is a governance issue, and we will come to that later. Maybe now I move on to Samhita, because Samhita, you have been working on, how to use robust data for decision-ready intelligence. And so could you elaborate how AI can be operationalized at scale to translate this complex climate and hazard data sets into decision-ready intelligence? Because AI is not about mathematical models. It is about taking and how it helps in taking decisions and actions. Yeah.
Thank you so much for the question, and thank you so much, Rita ma'am, for bringing us to Spotlight. Talking about disaster tech in AI for all has been a privilege. This is the first disaster tech. Everybody else or the other technologies that were lined up in this summit, we are the only ones who are talking about disaster tech. So the reason I highlight this is bringing it back to your question of data. When we started working with data, and a huge credit goes to Seeds as an organization for enabling it at the beginning of this journey, both Manu and Anshu absolutely pioneering the early adoption of various kinds of technologies. AI is just one of them. When we started with very lean data sets not trained, they were raw and they were unstructured. Body and the water network there, or the entire system of water. So these questions can be answered only if you have trained your data and you know where to look. That's number one. Number two, yes, AI has evolved from the time we started, from when I was in Microsoft to where we are today. We started off with only computational AI. Computational AI is how you compute millions and trillions, and you can just not keep a fingertip on the count of data sets that are coming. To generative AI, where it has started generating responses in a report format, because right now most of the hazard risk vulnerability assessments are paper-based. Takes 6 to 8 months, smaller area 3 months. Is there a way this can be generated through AI? Because then a village, which we are working with United Nations and NDMA, when we are working with these 80 villages right now, the villages are getting access to this. A village pradhan and a patel is using a system which is Resilience 360. Now that has converted the entire conversation of just computational AI, complex flood models, like flood velocity curve. I'm very sure ordinary people like me, I will not understand. But I am the administrator of that village, and I am the administrator of that urban or the city. And I have to understand it in a simplified way. That is generative AI. Simplify the information to land with the person who is actually taking the decision. The last and the most, this is our new launch and curtain raiser that we have made, is we have started building an agentic AI, and a huge amount of credit goes to the mentorship of NDMA. What we have started building in agentic AI is start plugging in your questions. Ask the question, where should I build? Okay, I have a school in this latitude and longitude, the way you use your Uber or your Google Maps to navigate from point A to point B. Just drop that. And what we will be telling you is, as an administrator, do you have the Disaster Resilience Index, which is very highly mentioned in the 16th Finance Commission? Can I budget it myself? So that is where we are taking the conversation of agentic AI, where do I need a 10,000 rupees or do I need a $10,000 is a huge difference. It's a difference from 10,000 rupees to an 80 lakh rupees. And that difference, if we can help the village authority in rural India or rural America, because we have started working in rural America, or if we can make the urban and the city authority to take the decision of, okay, I need X amount of dollars or X amount of rupees, and then submit it to the SDMA, it makes the life of SDMA in preparedness and mitigation much easier. And that's our latest launch that we have done in Resilience 360. Please visit us on resilience360.ai. That's where the system is.
Need to have a separate conversation with you to learn more about the work you have been doing. But if two takeaways for me from what you said is, even in a data scarce environment, AI can help us to generate data set, proxy data set, which can still help us to kind of plan and do the resilience planning and use every ounce of computational power to kind of come up with local models informed by citizens' voice and can be used by local government and authorities. In the SIDS session that happened on 16th, I heard about pocket-sized models. It was a very interesting concept on how we localize AI models. So thank you very much. We move on to our third speaker, and we have Dr. Saharia from IIT Delhi. He was also CDRI's fellow. He has done some very interesting cutting-edge research. Forecasting and early warning system are critical for doing infrastructure resilience. May I request you to kind of throw some light on how, by integrating geospatial science, hydrodynamic modeling, and machine learning, we can improve the accuracy and timeliness of, early warning for the infrastructure system.
Sure. So thank you very much. So I can maybe give two examples, and one of them is actually related to the CDRI fellowship when I was a fellow at the time, and some of us our team actually developed a new flood mapping tool. And I give that example because that can give a clear distinction between a pre-AI way of doing things and a post-AI way of doing things, especially in the context of flood mapping. So we developed two tools. One is for flood mapping and one is for landslide mapping. Now, whenever we are doing PDNAs, like NDMA is doing PDNAs, there are a lot of things to fill up there, and there is a way to there is a potential to accelerate at least some of those. Obviously, field surveys cannot be completely automated or avoided, that they add a valuable human dimension and a fine scale dimension that can never be covered by a satellite or an AI model. But at the same time, for rapid assessments, we can starting off from AI. So when it comes to, for example, flood mapping, the traditional way of doing flood mapping using satellites would be by looking at the imagery that you get an image before the event, you get an image after the event. You try to get the difference between the two images, and you build a flood map out of it. Now, that is the traditional way of doing things. Now, if you are able to train a model looking at all the flood events that have happened in India or across the world. So we trained this model over several months at our lab, and we essentially trained SAR data and existing flood events that have happened in the past. And instead of having hard cutoffs, so traditionally we would have threshold-based methods. So these thresholds are set by us, that if it crosses this threshold, you would call that pixel flooded. If it does not cross, you don't call it flooded. Now, that brings in a human dimension, is that the thresholds differ from place to place, and there are a lot of other factors that go into calling it flooded or not. Now, that part we can completely automate away using AI, because now you no longer have to, not only are you only relying on remote sensing data, you can bring in elevation models, you can bring in slope data, you can bring in other data sets into this trained model and be able to, because inference is really cheap. You can train this model over 3 months, but the inference, it only takes 1 minute to get a flood inundation map. So you are able to utilize a lot of information that traditionally we would never utilize. And same goes for landslide mapping as well, when we are looking at identifying what is the runout area. Is the runout area 1,000 kilometers square, or is it 50 kilometers square, 10 kilometers square? How much of it was affected by landslides, so that NDMA is prepared in terms of like giving out the payouts, in both immediate payouts as well as long-term reconstruction of that area. So I think that's one way that we can see how AI can be integrated with existing systems of looking at PDNA as well as other government way of doing things. But we don't need to like take the baby out with the bathwater, but in the sense, these models can be integrated with existing methods. They don't need to be taken as a completely new way of doing things. And I think that's the way that it can be integrated with current systems. Thank you.
Thank you.
Madam, I will be keeping my view with the experience.
Yes, sir, I'll come to you. I have a dedicated question for you, but because we have a,
No.
you want to intervene to the comment he made?
No. The right now how we are using it and how it has the relevance.
Yes, I'll come to you, sir, because we have a flow for the panel discussion, and I'll definitely come to you with your question. So, no, thank you very much. Dr. Saharia also heads the Hydrosense lab at the IIT Delhi. And maybe who is interested to know more about the work that they are doing, please visit the website and you get a lot of interesting stuff there. And we can definitely need to again have a separate conversation to know more about it. We have Anshu with us. And Anshu has been working with us a lot when it comes to resilient infrastructure. Anshu, if you can tell us about how AI and digital public infrastructure can reshape the way we plan, design, operate, and recover resilient infrastructure. You know what CDRI does, the kind of work CDRI is doing. What are the 2 to 3 things that you will recommend CDRI in order to kind of, come up with some transformative changes in the way we are working? So your oversight.
And I'm sure we'll see those transformative changes very, very soon. Let me go back and start from Satyabhaya and Kanupur. And the only thing that stands out in my memory, the most iconic image of Satyabhaya was a water hand pump, a stand post jutting out of the sea, right? So while we spoke about cyclones there a lot, but it was very slow onset erosion-based work that, pushed this village out. Very, very slowly. Initially, we couldn't even find the people. Then, like you said, they're in a new place and there's new risks. We speak about erosion again, but there's so many other risks. Because Kendrapada is also a heat hotspot. There are livelihood things that you pointed to. I think where we need to go, and specifically in the CDRI context, and I actually see Rakhi in the audience who's been working on civic data beautifully for the last few years. This is the time where we need to break out of these silos in which we've put our data. This is cyclone centric, this is hardware, this is infrastructure. It needs to merge, right? And it needs to merge globally. And hence, Ranjini, I think we need to talk very urgently about what opportunities are now emerging for our GIRI model and platform, because it can literally be put on steroids. And data sets that we've used in the past, MDAT that we've all used, NASA Earth data that we've all used, World Pop that we all use, there's already conversations about bringing all of this together. We need to be in that conversation. Very quickly, and thanks for mentioning the Pocket AI model. That was very interesting for me also day before yesterday here at the summit. And Sujit from UNDRR also spoke about how we need to be cautious that we might create glamorous apps, but it'll be very difficult for governments to use them. That is the resistance we are seeing globally. So how do you bridge that in the institutional frameworks? What kind of filters, what kind of policy doors we should look to you for opening so that the marketplace can come and create that relevance? And very lastly, digital public infrastructure. This has to be an India stack piece. We've been talking to METI and NDMA about this. I think the summit is a huge boost in that conversation. This is the year we must make all of that happen. Thank you, Ranjini.
No, thank you. Two very important points that you made, Anshu, that how to break the silos that exist between different data sets and how to build capacities at the local government level, because policymakers very rightly said, you can have fancy apps and technologies made available to them, but to put policy into practice, you have to work with them and you have to bridge that gap that exists between the technology and the policy.
And next week, when we will have more time, we must talk about capacity also. That
we will do that, definitely. So maybe I move on to Kimberly. And Kimberly, you come with kind of one of the most immediate challenges that whenever a disaster strike is the breakdown of communication infrastructure. And you come from GSMA, you work with mobile networks. So if you can tell us how you have been using AI, to kind of, and machine learning to build resilience of the mobile networks, particularly with a focus on low and middle income countries, because in CDRI, we work a lot with these low and middle income countries across the coalition.
Thank you very much, and thank you to CDRI for having us here. I'll let the audience in on a small secret. There's a sign at the back that has a countdown clock, and there's 2 minutes left and 2 speakers. So I'm going to try to be, for our dear moderator, I'm going to try to give some brief examples so our last speaker can also have a few moments before we wrap up. But as mentioned, I work with the GSMA, and we work with our members, mobile network operators, to leverage mobile networks for disaster resilience, disaster preparedness, and we work a lot on early warning systems, on using mobile networks to set up cell broadcast and location-based SMS. And we're seeing more and more use cases of using AI to leverage better resiliency of mobile networks and to enhance these systems that we're working on. So we see a few different examples, and some of that is to do better weather prediction. Some of that is to protect mobile networks and make them more prepared for disasters. And so one concrete example, we talked about flood prediction a bit here. We're working with the government in Madagascar and also with the International Telecommunication Union on setting up alerting, and we're leveraging Google's Flood Hub that uses AI in Madagascar and using the information, the predictability of floods, and then partnering that with our mobile networks and with the government to send those alerts and to reach people in a faster way. You see other examples of mobile network operators, for example, leveraging AI. So when we talk about extreme heat, we see now the capability to trigger cooling mechanisms to make mobile networks more resilient. Or in the case of being aware that a cyclone or a hurricane might be approaching, you see on mobile towers adapting or removing the antennae when you know that a cyclone or a hurricane is approaching. The final example that I'll give is we work again with the International Telecommunication Union on something called disaster connectivity maps. And that's in a disaster, you want to know where connectivity is, where it's down, the status of infrastructure before and after disaster. So we leverage also AI to look at population movement so that you can really empower humanitarian responders and affected communities to be able to leverage existing infrastructure and restore it where it's down. So I'll leave it there and keep it brief, but thank you very much.
Thank you. No, thank you very much. As I said at the very beginning, it's really pity. We have such a esteemed set of speakers with us who can really bring in so much of insight, but we do not have the time. But still, I think you touched upon 2 very important points of like predicting flood events and sending alerts to the community, and also kind of building the resilience of the mobile infrastructure itself from the impact of heat or high wind speed and all. And Madagascar is a member country of CDRI. So it is all the more interesting to know that you have been already working them, and probably we can actually discuss more on how we can have a more concerted effort together to support that country. We have with us Dr. Panigraha. Thank you very much, sir, for joining us. I know I couldn't give you the floor before, but I have a very dedicated question for you. And you come, for those we didn't introduce him because you were not here. He's a leader in sustainability. He has been worked with the government of India. He comes with several decades of experience. He was part of UNFCCC CCC negotiations. He's also, if I have to introduce him, I need another extra 5 minutes to do that. But in interest of time, what I would request you is that we are all talking about using AI, but there is also something called ethics of AI. So because you work with the International Institute of Social Development, if you can touch upon that, how inclusive and, how can we ensure that, when we use AI for disaster resilience, it results to equity, it reduces inequalities, and it also kind of help us to address the issues and challenges of the marginalized groups.
Thank you, ma'am. Although you could not able to tell my name correctly, introduction correctly, institution correctly, the question correctly, anything, all were wrong. So I am Dr. Srikant K. Panigrahi, not Panigraha. and there is a lot of difference between both the words. And I'm a leading civil servant and policy maker. I have worked with Government of India, World Bank, and United Nations Environment Program in a span of 37 years. And right now, I am leading a public policy think tank and scientific research organization that is Indian Institute of Sustainable Development. So, as a decision maker, I have always preferred research-based decision making, and I have always given priority analytics-based, research-based decision-making process. Now, while heading the scientific organization, we have started using AI. I'll not, in the interest of the time, I will keep it very brief. I will explain the 3 different areas we are engaged and doing the research as well as kind of the engagement in different projects. First thing is urban heat waves mapping and urban heatland identification, and this is through satellite imagery. We are doing analysis by vulnerability assessment, and if you will see in Delhi there were 34 deaths between March 16 to June 23rd last year, and that is also in 2 different location of the city. So it is very much essential to identify and do the mapping of the solar radiations which are having largest impact, which could be as dangerous as death. So for that, different modeling we are doing, which is till now, which is not AI based, but AI based analysis will help us to get more accuracy. It will reduce our time efficiency, and it will make us intelligent based research. We are in the panel of Reserve Bank of India and SEBI for climate risk modeling, and risk modeling for the projects while doing the financial due diligence. Suppose we have spoken a lot about flood related AI modeling. Take for example a small town in Bihar along the river Kosi, and Kosi is starting from Nepal, and it has a flood impact every year. There are different projections, but none of them are so accurate. Like as per World Bank gives a standard how to assess the damage losses, likely damage losses through natural disasters. There are various kind of disasters, say for flood. So how many man days will be wasted? How many lives are likely to be go? And how much property and infrastructure loss is to be done. So this kind of assessment for that, the banking.
Sir, I'm really sorry. They're pushing us that we have to vacate the room. The bell is ringing.
Yes.
So my sincere apologies for
So-
pronouncing your name incorrectly and also pronouncing the institution incorrectly.
Man, that
but,
is understood. Don't
But we can
waste
we
time.
can do a bilateral discussion, so we have to vacate the room.
Yes,
so you
yes.
may take another 1 minute, and if you can conclude, please.
Ma'am, there was no need to tell this. By
Yeah.
this time, I could have finished. So, so it is a disturbance to my flow. So the coming to the kind of the mapping of anything, the AI-based intelligence will make us very efficient and do the accurate estimations. That is we have done. We are now going to do a project with Anusandhan National Research Foundation, where we through AI-based modeling, we are trying to enhance the pollination rate of the bees in apiculture, and thereby enhancing the livelihood security of the poor tribal women who are surviving on apiculture.
Thank
So
you,
that's a
thank
very
you.
interesting model.
Thank you.
And-
I think we have to end the panel discussion. It's okay.
Session, that's only.
Yeah, that's the reason, but we have him with us, so we can always have, the participants can have a conversation with him outside, but this session needs to attend. So thank you very much, sir. Thank you very much. Yeah, you can complete.
Thank you.
Thank you.
Thank you. I would request the speakers to, I would request India team, Mr.